Hello. Here, let's think about an example. So suppose that you are a professor and you can choose a student to who wins the Academic Excellence Award, suppose. Suppose that there are two candidates for the Academic Excellence Award and you have to choose one based on their grades, right? And so in their major courses, economics courses, student one got these uh, grades, and the other student got these grades. So these are your data. You have to make a decision based on those observations. By the way, the outcomes are not numerical. So even though you can compare between A and B, but they are not numbers. So, like actually you can, but you cannot add or subtract, multiply or divide. So the basic operations are not applicable to to this data. So this is not convenient, but you know how we define their numerical description, how we define a random variable, right? So this is how we convert the letter grades into numbers, right? So this is random variable, and it's a function. A is assigned to 4.0, A minus assigned to 3.7. So it's like a function, and still, okay, it's better. It's now we are ready to manipulate the data. It's much better to handle. But we need to summarize this data because, uh, like from these 10 numbers, it's hard to see who is better, whose grade is better. So we need to summarize uh, and compare. One possible way to summarize the data is to make a frequency distribution table like this. We did it in chapter 1. So A minus, B plus, B minus. So student 1 has this record. So it got A in one class out of 10, and 4 in 4 classes got A minus, like that. And student 2 got this record. It shows how many classes, how many classes a student got a certain grade. But again, it's a nice summary. So it is a summary, but hard to see who is better. Now we have to compare and decide whose grade is better. And another way that helps you compare them is to make a histogram. So this is I made it as a line chart, but you can make it as a bar chart. Does not make a difference. But anyhow, if blue is student 1, and it means in the blue student 1 got B0, B flat in 2 classes, right? B flat in 2 classes, and A minus in 4 classes. So exactly it is based on the frequency distribution table. And it is also easy to understand the histogram because a greater outcome goes in this direction and more likely as you go in this direction. So if the table is converted visually in this way and put two students in the same graph so that we can compare them. Then what can we say? We can say student 2 has more classes in which he or she got A. So more A, student 2 got more A's. But at the same time, student 2 got more B minus, which is the worst grade of these two students. So it's uncertain. Still, it's uncertain. Who is better? If you look at this, if you compare this part, student 2 is better. But if you compare this part, student 2 is worse. Right? So, like better in good grade, but worse in bad grade. What we need is we need to summarize the data further to compare, to make a direct one-to-one comparison. That is why we use the average. Average does that. That's the role of average. In the end, we need one number to make a comparison. We need to summarize all the data into one number so that we can compare which is great, which is smaller. And that is the average. And that's why we use GPA. GPA of student 1 is 3.47 and the other student has 3.44. So you know now you can compare which number is greater. I'm going to choose student 1 because that student has the highest, the higher GPA. So this is the role of the average. By the way, it's not perfect. I'm not saying the average is perfect, but it is the most common way, and everyone uses and understands what the average is. So that is why this is the most typical way to make a decision, and it helps you make a better decision and easier decision. So, and we are going to extend our concept from the average to a measure of central location. So what actually it does is it captures, the average captures the location, the representative value, or the center location of the grade distribution. So grade is distributed between 2.7 and 4, and then what we are looking for is the center, where the center is, right? The center is like somewhere here. So it doesn't need to be the average. Later, I'm going to show you alternative measure, and as long as you use a measure of central location, it will do the same thing. It does the same role, so can replace the average. But anyhow, the point here is the average is to summarize the data like in a super compact way into only one number. So it is to represent the whole data by one number. That's it's super convenient to have only one number and to make a comparison, and that's the average. Okay, and I already explained these slides in the earlier slide. So a measure of central location or central tendency is a value around which the data are located or centered. So we would like to look for just one value. So it is a typical or representative outcome in the data. So, right? And examples we are going to learn in this course are mean and median. Mean is the average, and median is an alternative. So later, I'm going to introduce you what is the median in a few videos. Okay, see you in the next video. I'm going to give you, in the next video, we will study how like a more concrete, more rigorous definition of average and how to calculate an average. I'll see you later.